Let's start with a shape we all know, a square. If you have a square farm plot with an area of 4 square meters, finding the length of its side is straightforward. You just need the number that, when multiplied by itself, equals 4. That side length is 2 meters, which is the square root of 4. Now, imagine a smaller plot next to it. This one has an area of exactly 2 square meters. By the same logic, the length of its side is the square root of its area. We write this side length as the square root of 2. We can draw this shape and measure out the plot of land. It physically exists in the real world. But that raises an investigative question. What is the actual numerical size of that side? While the square root of 4 is a whole number we can easily name, the square root of 2 isn't so obvious. To find its value, we need a way to hunt it down. We start by establishing boundaries. 1 squared equals 1, and 2 squared equals 4. Since our target area of 2 falls between 1 and 4, the length of the side, the square root of 2, must live somewhere between 1 and 2 on the number line. To get closer, we test decimals in the tenths place. Looking at these computations, we multiply 1.1 by itself, 1.2 by itself, searching for the result closest to our target area of exactly 2. By checking the results, we find a tight boundary. 1.4 squared gives us 1.96, which is slightly too small. 1.5 squared gives us 2.25, which is slightly too big. By finding the numbers right above and below our target, we've successfully trapped the square root of 2. It has to be greater than 1.4, but less than 1.5. This squeezing technique works for any root. By repeatedly testing and trapping the target value between upper and lower boundaries, we can calculate lengths even when they don't map neatly to whole numbers. Now it's your turn to shrink the trap. We know it starts with 1.4. Take a moment to pause the video and calculate the squares of 1.41 and 1.42. Here is what those calculations look like. 1.41 squared is 1.9881. 1.42 squared is 2.0164. Because 2 falls between those results, our trap is now much tighter. The length of our square side is sandwiched between 1.41 and 1.42. If you look at this circle detailing the remainders, you can see the gap continually shrinking. We can repeat this process for the thousands place, the 10,000s place, and beyond, getting nearer and nearer to a perfect area of 2. Each time we add a decimal place, our calculation gets more refined. This process allows us to hunt for a measurement that becomes more precise with every single step. As shown in this yellow box, calculating out to 5 decimal places gives us 1.41421. Because writing endless digits is impractical, we write it in a shortened form, ending with an ellipsis to show the numbers continue. This wavy sign means approximately equal to. This logic extends to other shapes. An equilateral triangle's height is the square root of 3, approximately 1.732. Generally, the square root of x is the side of a square with area x. Whether it's a whole number or a complex decimal, a square root gives us a concrete way to translate an area back into the physical dimensions of the world around us.